Hello, this is Mr. Stein, and in this video we are going to go through the example problems for section 5.1, representing relations. If you remember, in this section you should be able to define and give examples of relations, represent relations in 6 ways, classify relations as one-to-one, one-to-many, or many-to-one, identify the domain and range of a relation. Let's go down to our example problems. Example number 1. Animals can be associated with the classes they are in. So the ant is in class Insecta, eagle Aves, snake Reptilia, turtle Reptilia, whale Mammalia. Let's just take a quick moment to identify this as a T-chart. Table of values. It's a table of values. The animals are our domain, and the class is our range. Letter A. Describe this relation in words. So an animal belongs in a class. So an animal, an ant, belongs in a class, Insecta. Letter B. We're going to represent this relation as a set of ordered pairs and as an arrow diagram. All right, so let's do the first one, ordered pairs. So we start our set with that squiggly brace. Then our first ordered pair will be ant, and it goes into Insecta. Now, I'm abbreviating it with a capital I since I don't want to write out Insecta, the whole thing. I think that's okay. Eagle goes into the class Aves. Snake goes into the class Reptilia. Turtle goes into the class Reptilia. And lastly, whale goes into the class Mammalia. Then end our set. That is this relation put into ordered pairs. Now our second one is going to be an arrow diagram. Our domain values go first, which is our animals. Ant, eagle, snake, turtle, whale, and our second set, which is our range set, these are our classes. Insecta, Aves, Reptilia. Now I only put one Reptilia in, and Mammalia. And I connect them. Ant goes to Insecta, eagle to Aves, snake to Reptilia, turtle to Reptilia, and whale to Mammalia. We just took this relationship between an animal and the class it's in, and we represented it in 3 ways: in words, in a set of ordered pairs, and in an arrow diagram. Now, we can ask ourselves, is this a one-to-one, a many-to-one, or a one-to-many relation? Well, let's look here at this guy, right here. According to this is going to be a many-to-one relation. There's many items in the domain going to one item in the range, remembering that many just means more than one. Example 2. Different towns in British Columbia can be associated with the average time in hours it takes to drive to Vancouver. Consider the relation represented by this graph. Here we have our town. Here we have the time. This is the average travel time to Vancouver. And our domain values are down here: Horseshoe Bay, Lillooet, Pemberton, Squamish, and Whistler. And our range values are the times. We're going to represent this relation 2 ways, as a table and an arrow diagram. So table. Our domain values go first, and domain is the towns. Our range is the times. Horseshoe Bay, again, I'm going to abbreviate them. Lillooet, Pemberton, Squamish, Whistler, so long as it's obvious what these stand for, you can abbreviate them. Horseshoe Bay looks like 3/4 of an hour, or 45 minutes. Right, to me that looks like 3/4 of an hour. Lillooet looks like 4.5 hours. Pemberton looks like 2 hours, 45 minutes. Squamish appears to be 1.5 hours. And Whistler appears to be 2.5 hours. Now, I can rewrite these times all as decimal numbers. So this is 0.75 of an hour, and this one is 2.75 hours. That way they're just all the same. So there's our table of values for this relation of a town and how long it takes to get from that town to Vancouver. Now we're going to represent this as an arrow diagram. We draw our two sets. We have our towns on this side and our times on this side. Towns are our domain, times are our range. Horseshoe Bay, Lillooet, Pemberton, Squamish, and Whistler. Times 0.75 hours, 4.5 hours, 2.75 hours, 1.5 hours, and 2.5 hours. And then we connect the town with its time. Now, what type of relation is this? Well, right now it looks like it's a one-to-one relation. With just these domain values and these range values, it is just a one-to-one relation. One domain value goes to one range value. If we extended how many towns there were, we might get this to become a many-to-one relation. But with the towns that we have, it is just a one-to-one relation. All right, I'm having a little bit of troubles with this application, so I'm going to have to quit it and reopen it. And hopefully that'll fix everything. All right, let's take a look at example number 3. Given this diagram of a relation, English words have this number of letters. So it's English words going to natural numbers. So an English word has this number of letters. And our range is all the natural numbers, could be the natural numbers. A. Describe the relation in words. An English word has this many letters. So this is a relationship between English words and numbers. And the relationship is how many letters there are in the word. Now they write down that this is the natural numbers here because you can't have a negative number of letters in an English word or a decimal number of letters in an English word. So it is just natural numbers 1, 2, 3, 4, 5. You can't even have 0 letters in an English word. So we're going to list 2 ordered pairs. First word, on. On goes to 2. Why does on go to 2? On has 2 letters in it. 2 goes to 3. Why does 2 go to 3? Because 2 has 3 letters in it. It's an English word. Our domain value in English word has this many letters in it. There's our range value. Our next one, I'm going to do one more. 3 goes to 5 because 3 has 5 letters in it. And one more, 4. That one's nice because 4 actually does go to 4. Now, is this the whole relation? No. This relation is described in general terms. It should include every English word and all the natural numbers that they go to. Unfortunately, I can't do that for every English word and list out every English word and how many letters it has, because there's just too many. So this is just a little piece of the relation. All right. If you have any questions about this, please